Okay, so this is the start of chapter 11, and we're going to break this lesson into two videos, so two sections. One is going to deal with the idea of arc length. That's this idea, and then the other one, so we'll call that the first one, and then the second one is going to deal with this idea of a radian. And circumference is actually something you've already seen before. So circumference is the perimeter of a circle. So we'll write that in there, perimeter of a circle. Or another way to think about that is the distance around the outside. And that's just it's a concept you've encountered with circles before, as well as area. And you've done that with all the major shapes prior to getting to a geometry class. But we'll do a little reminder on it, and then we'll talk about these two big ideas of arc length and radian for this particular lesson, and we'll break it into two different videos. So this video is going to be about arc length. So for starters, circumference. We need that to talk about arc length, and just as a reminder, circumference of a circle is pi d or 2 pi r. So pi d, pi times diameter. So d is diameter, that's the distance across a circle from left to right through the center, or up and down, I guess it could be in this picture, it's left and right, or circumference is 2 pi r. And I think when you're first learning it, I think the 2 and the r being separate can sometimes be a little harder to see. So you can think about it like pi times 2r. So if you think about what diameter is twice a radius. So diameter is 2 times as long as a radius. So the reason these two equations give you the same thing is they both have a pi and they both have 2 times the radius, or diameter is another way to write that. In mathematics, this class and going forward, this equation gets much more heavily used. They're both equal, they're both good, and there's nothing wrong with either of them. What they do is they just say, okay, let's take this circle and what is the length around the outside? So if we were to say that was an actual physical circle made of string, you cut the string, lay it flat, measure it, that's what you're getting when you look at a circumference. And you've seen that idea before. That's not a new concept for you. But what we're going to do with the concept is we're going to say, okay, you know what? Actually, we could come up with just a little piece of the outside. We could come up with that little spot right there, that arc. And that arc has a length to it. And we could compute the arc length. And so that's going to be this first video, is just saying, okay, we can actually come up with a way now, based on what we did in chapter 10, to come up with just a little piece of the overall circle. And that's the next page of notes. So if we scroll through the next page of notes, which I'm hitting a wall on here, so let's jump over here. I think I've got another page of these things saved. Maybe I do not. Okay, here's that second page of notes. Sorry, I had to pause it for a moment and just locate it. I got printed to another spot. But this is the second page of notes. So we just talked about circumference, and now we're going to talk about arc length specifically. So when we're looking at a circle, you can find the distance around the entire outside. So the entire outside is the circumference. So the circumference is the whole way around. Or, and I'm looking for my highlighter here, we can, let's see, we can just do a piece of it. So let's say we're just looking for that specific little piece. So what we're after then is the length of that arc, or the arc length. And we usually call it arc length of AB. And all that is the distance for that little yellow arc. So instead of computing the whole thing, we're just going to go and do a little piece of it. And the way you do it is actually a pretty simple way, and it's kind of cool. We're going to blend what we did last chapter with what we did this chapter. What we're going to say is, let's make a ratio. So the way you make a ratio, part over whole. So part over whole. We can do that with distances. And then part over whole, we can do that with degree measures. So degree measures. And the degree measure of an arc is something that we did in chapter 10. So this was what we did in chapter 10. And what I'm getting at here, I'm trying to give a little more context to this equation right here. So what this equation does is it takes part over whole. So each of those fractions is part divided by whole. which is a sneaky way of just doing a percentage. So if we do part over whole, and let's look at just the right-hand side of this thing. So I'm just going to highlight this right-hand side. This is from chapter 10, measure of an arc length. Well, that's a degree measurement. So we have the degree measure of this arc length. And whatever that degree is, when we divide it by 360, that's the total degree in the circle. So this is part divided by whole. It's the degree measure of AB divided by 360, which is the degrees in a circle. And so let's write that. Let's say degree measure of the arc. So I'll say AB divided by the 360 degrees total in the circle. And whatever that ratio is, whatever that percentage is, or whatever that decimal or fraction, whichever word you want to use, and I know those can be scary words, but they're all the same thing. That same percentage is the percentage of the arc length divided by 2 pi r. Well, what's 2 pi r? That is the circumference. So that is circumference, which is total distance. So just like on the right-hand side in the yellow, we have 360 total degrees. The left-hand side circled here, the 2 pi r, is total distance. And then on top of the total distance, we have what we're calling the arc length. So we have arc length AB. So we've got distance on the left, and we've got degree measure on the right. And all we're doing is saying, whatever amount you're using, you're going to get the same percentage if you divide part by whole. And we'll do an actual problem here that I think will highlight kind of how that works. So as an example, and I'm just going to put it over here, and we'll do some actual formal examples here in a moment. But as an example, if we were, let's say we had a circle, and let's say we had a radius of 5. So let's say the radius was 5. And let's say we wanted to come up with the arc length for a 90-degree central angle. So I'll just use my highlighter here to indicate I'm doing the same thing I've been doing. So I want that little chunk of the circle. Okay, well, if I want that little chunk of the circle, first off, I need to know what the whole circle is. So the whole circle, the whole circumference, we're going to use that circumference equation. That would be 2 pi r, or 2 times pi times 5, which would be 10 times pi. And pi, I guess we didn't say it. I maybe assumed it and shouldn't have. Pi is just a Greek symbol that's a mathematical constant that's roughly equal to 3.14. And we can pop over to our calculator here. I'll clear out what I was doing. If I do pi, just hit pi, the pi key, and hit enter, it'll give you the 3.14 value. And if I did 10 times pi, that's going to tell me how far around on this circle we are. So 31.4 if I were to round to the nearest tenth. So that would say my circumference is the whole thing is 31.4. So now I want this yellow arc. Well, I want part of it. So I want part, or the arc. We'll just say arc length. So I'm going to take part divided by the whole thing, 31.4, and that's going to equal 90 degrees in the middle. So there's my 90. Part divided by whole. So again, part divided by whole on arc length, part divided by whole on degree measure, and whatever your central angle is, it's the same number of degrees in your arc length measure. 90 divided by 360 is 1/4, or 0.25, which shouldn't be surprising. There are 4 of those in a circle, so that's 1/4 of a circle. To isolate or get arc length all by itself, I'm going to multiply both sides by the circumference. So I'm going to multiply both sides by 31.4. So again, 90 divided by 360 times 31.4. So let's go over here to the calculator. 90 divided by 360, hit enter. There's my 0.25, so 1/4 times 31.4. And I get, 3.4. I didn't mean to do that. Let's clear all this out. So let's try again. 90 divided by 360, so I'll get my 0.25. And then I'm going to multiply that, we said, by 31.4. There we go. And then hit enter. And I got 7.85. We'll call it 7.9. We'll round. So what that means is my arc length would be, what do we say, 7.9? Would be 7.85 or 7.9. And what that means is we're just doing a part of the whole thing. We're actually specifically doing a fourth of the whole thing, or 0.25 of the whole thing. And that's what this equation is. So that's what this boxed-in equation is. It's just doing part over whole of the sides and part over whole of the degrees. And then this bottom equation, that I would prefer we just look at this top one and just use that, because you're going to be, there are 4 total pieces, top, bottom, top, bottom. They're going to remove one piece, ask you to go solve for it. It's not always going to be the arc length you're getting, which is what they did on this bottom equation. They actually did what we did. They multiplied both sides by 2 pi r. So they multiplied both sides by the circumference. That's our 31.4 number. To come up with that bottom equation, you can always use this top equation. Just do part over whole equals part over whole, and you can solve for whatever it is you're asked to solve. Okay, so let's actually do a couple examples. So we'll scroll down to these example problems. We're just going to do the first 5. First 4 all have to do with circumference of a circle, and then this last one is the arc length problem, which you can see instead of a 90, they have a 70, really similar problem to the one we just did. So first one, diameter of a circle with a circumference of 10 inches. So circumference equals pi times diameter. That's an equation that has both the 2 things we're looking for in it. Circumference is 10 times pi d. We're going to divide both sides by pi. So we're going to take 10 divided by pi, and that will be our diameter. So we'll go over to our calculator. We'll do 10. Oops, clear that out. 10 divided by pi. And that's going to give us 3.18. We'll call it 3.2. So diameter is 3.2 inches. Second one, circumference of a circle is what we're trying to find with a radius of 3. So circumference is 2 times pi times r. So 2 times pi times 3, which would be 2 times 3 is 6, so 6 pi. Sometimes you just leave it as 6 pi, or if you're asked to round, you just go to your calculator and literally hit 6 pi and let your calculator do the work for you, and it's 18.8 in this case. So we'd say, okay, that's 18.8 centimeters. And if you're not given specifics as to what to round to, technically those are both equal, but we'll just call it 18.8. This next one, we're looking for a radius of a circle with circumference of 8 feet. So we've got circumference is 2 times pi times radius, or circumference we know is 8, and what we want to find is the radius. So we're going to take and divide both sides by 2 pi. And that means 2 and the 2 will cancel, pi and the pi, and we're left with just r. So then 8 divided by 2 pi, we punch into the calculator. And I'm going to use parentheses just to make sure it's dividing by both 2 and pi. And that's going to give me 1.27 or 1.3. So we'll go here, and our radius is 1.3 feet. And then last one of these circumference ones, we got circumference of a circle that we're trying to find with a diameter at 2.4. So here, again, we can use the pi d equation, which is a little less used, but here they've given us a diameter. So we're saying pi times 2.4, and you would just punch that into a calculator. So we would do pi times 2.4 and let it come up with a decimal for us. So it'd be a 7.5. So we'll go over here and say, okay, that's 7.5 meters. Finally, and this is definitely the more challenging question on here, the arc length of AC. So we're saying, what is this length? Well, we know if we have a central angle of 70, the arc measure from chapter 10 is 70, those match. So if we do our part over whole, we've got 70 over 360. And then we need to do part over whole for distance. So again, that equation will always work for you. Part over whole of degrees, and then part over whole of distance. Well, we're looking for the part. That's the AC that we're looking for. So 70 over 360 is going to be our arc AC over whatever our circumference is. And in this case, we actually need to go find the circumference. So we need a circumference for a radius of 3 inches. So we'd say 2 times pi times 3. Well, 2 times pi times 3, I think we actually already did that. That was up here in number 2. So we don't have to go and redo that one. So that one's here in number 2. And that's going to be, what, 18.8. So it'd be 70 over 360 equals AC over 18.8. And I'm going to run short on time on this one, so I'm going to pick up with a part 2 video in a moment.